environmental systems teacher coming to you from here at MacArthur High School today to talk about water, the resource. So we're going to do a little bit of general information first about water, the resource. Even Leonardo da Vinci pointed out that water is the driver of nature, and the other nutrient cycles couldn't happen without the hydrologic cycle and all the properties of water. So start listing properties of water. One of the most important ones is this strong attraction force between molecules of water. It means that it has high adhesion and high cohesion, so that when it flows, it can stick onto capillary walls and flow straight up automatically all the way up to the tallest sequoia, and it can carry big amounts of momentum with it, so that when it flows in a river, it can carve out the Grand Canyon. Water will change temperature really, really slowly. In fact, it takes a lot of energy to get water to change temperature. So that means when there's a lot of water vapor in the air, as in humidity, it signifies lots and lots and lots of energy in the air. It takes water lots of energy to turn into water vapor. So again, when there's a lot of vapor in the air, it signifies lots and lots of energy. When backing up to heat capacity, when bodies of water change temperature, like the ocean or like a lake, when it freezes, it means that lots of energy has changed hands in order to get that to happen for every degree of temperature that has been changed. Sorry for the gory looking picture, but this is to point out that when we throw things onto the street, when we throw things onto the grass, they don't just go away. Every time it rains, water will flow downhill, and things look brand new the next day, but the water that flowed downhill gets horribly contaminated because of this high attraction, not only between its own molecules, but between other molecules. It dissolves so many things so efficiently. It's a nice thing when you have to clean something off, but it's a really, really, really difficult thing when you're trying to keep water clean. Water expands when it's frozen, so it can get at the tiniest crack of the most enormous boulder, and that might be the only thing that breaks it up when the water freezes. Okay, so small review of the important parts to us about the hydrologic cycle. We have, for example, things like streams, rivers, lakes. A lot of them get kind of like filled up through precipitation or through maybe glacier melts. A watershed, just FYI, is not the river or the stream or the lake itself. It's the land that the raindrops fall on and then flow downhill to that certain river or stream. Groundwater is the water that flows underneath. And so while things are flowing downhill along the surface, they are also percolated down through the soil and the rocks, and they flow downhill under the ground. We know this really well because we live right over this enormous and rechargeable Edwards Aquifer. Provides us with some of the best water in the whole country. Speaking of providing us with the best water in the whole country, we have to monitor our water usage. Irrigation is the top user of water. Definitely write that down. Industry comes in next. We come in last in our homes and in our workplaces and our schools. So we think that we use a whole lot of water, and we do. Every time we flush the toilet and brush our teeth and do our laundry. But the amount of water that we use at home and at work and school doesn't compare to the amount of water that it takes to water our crops. Okay, we're going to start looking at some problems with water usage. So obviously there are issues of flooding, and we're going to look at where those come from. It might be heavy rainfall, it might be a snow melt, it might be where you're located on a floodplain. And so people do certain things. They might actually plant a wetland to help provide natural flood control. Maybe they'll narrow a river, maybe they'll use a levee, maybe they'll use a dam. So here's an aerial view of of St. Louis, Missouri under normal conditions and under flooding conditions where the river just swells to enormous proportions. Here's some possible reasons why. So when we do deforestation, we take away these trees' ability to hold back some of that downhill flow. Also, trees are very water hungry organisms and they will soak up a lot of that water, so they protect the area down below. If they're not there to protect the area down below, we'll have the water flowing downhill quickly, and we'll also have the water picking up a lot of soil on the way down. That means this soil here gets eroded and this water here gets polluted. Okay, so here's some issues of too little water. Obviously that's droughts, and that's something called desertification. Here where we live in a grassland type of area, we're very susceptible to our area becoming a desert when we have drought for too long. So here's an aerial picture of a place in the Soviet Union where this started to happen. This was the lake before, this was the lake after. And in the Aral Sea disaster, a lot of water was diverted. And so we lost a lot of the productivity from the wetlands. We lost a lot of the biodiversity from the bird life. We also ended up with a much, much higher salinity or saltiness because the water evaporated and left the salt behind. If the water underneath the ground gets depleted, then we have some organisms that are put at more risk, like our little blind salamander. He's world famous. Once we pour river water or lake water onto the soil over and over again, you have to remember it's not completely pure. So as we irrigate year after year after year after year, we're leaving behind just a little bit more impurities every year. And after a while, so much of it has built up that nothing will grow there anymore. Usually those impurities are in the form of salt. That's why we call it salinization of irrigated soil. Okay, specifically in the U.S., we have some exotic species that get introduced and end up taking over, like the zebra mollusk. It populates really, really quickly. It sticks onto a whole lot of surfaces, like pipes, like dams. We end up with places with too much nutrition. This is what is called cultural eutrophication. That is not a golf course. That's water underneath there. That's not grass. That's algae. So this is what it looked like when it was clean. This is what it looks like when it has too much nutrition in it. And that's a bunch of algae growing on top. So water that's undernourished, oligotrophic, would look like that, very clear. And water that's eutrophic, has lots and lots of nutrition, would look like that, with a whole bunch of algae growing into it. Neither one of these is an indicator of human interference or human effect on its own. But very often, too much nutrition in the water is a result of human effect. Too much of a good thing. So when the extra nutrition in the water, the eutrophication, is because of humans, we call it cultural eutrophication. This is one that if you haven't written it down yet, you definitely need to pause the video and write this one down. Let's see, the Dead Sea in the United States is another example of the salt concentration being extra high because it's been drained, the water was drained and the salt was left behind. And the Colorado River Basin is the famous, enormously powerful river that powers Las Vegas. This is the river that carved the Grand Canyon. This is the river that powers the Hoover Dam, and because it's been dammed up so many times along its length, it no longer makes it to the ocean. So this river is enormously powerful, all the way up from close to its headwaters. It doesn't make it this far. It doesn't make it to the Gulf of California anymore. Yeah, a lot of people consider it an overtapped resource. It's been dammed 14 times. It's been made into lots of reservoirs, lots of canals. Let's see. I think I'm going to have to talk to you guys about groundwater in class because we're going over time by over a minute now. So thank you for your patience through this video. Everybody make sure you take good notes today watching